Hello everyone, this video will guide you through XIFI use case 12 about the innovation pathway. The showcase is about how to move from an idea to a business. There's no cookbook, and the specific experiment we describe is not completely generalizable, but it will show what you can expect at each stage, providing recommendations to the EC community and to the infrastructure owner. To compare the different testing facilities, qualitative metrics were used. In fact, if you're an infrastructure owner, someone raising capital or a public body financing infrastructures, you will find it particularly interesting. The innovation pathway we're interested in here is how an entrepreneur gets from a good idea to a business. This process can be seen as a succession of stages and requires changes to many aspects of the proposed solution, including technologies used, business models, and mindset. With the specific case we're looking at, we start with an experimental facility such as Ofertie in fire, and move the experiment to a pre-commercial environment like XIFI, so that we can open up the potential and scale the environment up towards exploitation worldwide. Let me tell you a little story. About 2 years ago, Pippa and her friends created an attractive online game that immediately took off. They were using a local data center and adopted a business model providing different services to different classes of user. With the community growing, though, they began to see more and more congestion and an overall drop in quality of experience. Some users started complaining and even left the community for this very reason. To resolve the issue, Pippa thought about using the benefits of software-defined networks, and so using an emulator should create an environment where the application could configure the network according to load. But she didn't have the hardware for an SDN-enabled data center. Pippa tried to use an off-the-shelf solution like Amazon, but she wasn't happy because there was no advanced QoS management support, and the SLA is completely one-sided. Pippa searched for experimental facilities and found the Ofertie project. She got a public grant to collaborate with them, migrated her homemade data center to their island, and was able to set up a proper environment where she was completely in charge of controlling the traffic. The experience was challenging, and she had to work through many issues, but in the end she ended up with a complete working environment providing full support to their application. All user classes are very happy and the community keeps on growing. Each user gets the experience they are willing to pay for, but the grant's running out and it's now time to think business. Pippa realized that what she really needed was a fully operational environment to test the scalability of her system, and XIFI seemed to offer what she needed. Her business's strengths include the application itself, the community created around it, and above all, the mechanism for QoS control she'd created. So, will she be able to maintain all of these strong points while exploiting an operational environment where the number of users is not an issue and someone else looks after hardware maintenance and availability? The answer to the first 2 points is simply yes, while she realizes that her QoS control system cannot be implemented in a federated operational multi-tenant environment. So does she need to drop this basic part of her idea? The answer is a resounding no. XIFI supports innovation, including QoS. Pippa needs to strike a compromise between what she does and what the infrastructure takes over so that she doesn't lose the benefit of her idea. XIFI defines a set of QoS policies identified by names and presented to the application owner so that he can choose between them. Each policy can be attached to the source of the traffic so that it is possible to discriminate among end users and provide the right quality of service to the right person. The application owner can switch on the fly among different policies. When Pippa reads this well-documented behavior in the XIFI catalog, she realizes it might just work for her too. But she knows that though some end users may be satisfied with the qualitative distinction among different QoS levels, that's not enough for hers. So she gets in touch with the XIFI Federation to get a precise mapping between the qualitative parameters and the technically quantitative ones. In so doing, she also discovers that XIFI is open to a discussion about specific configurations to support innovative applications. After a brief yet fruitful collaboration, she is then ready to fully exploit her innovative idea. XIFI adds the new configuration to its offerings, thus making the benefits available to all. Coming back to the actual use case, 2 experiments were carried out, one analysing data for network profiling purposes on different infrastructures, and the other testing the QoS management feature available in the infrastructures. This table summarises what we did on the different infrastructures. And so here is the architecture used in Amazon. It's a standard cloud architecture which gave us public IP addresses, and so we were able to get data from real users. This is the equivalent in XIFI. It's analogous to Amazon, and the data gathered are very similar. So this proves that XIFI can be used in an Amazon-like fashion. And here we have an example of where network profiling detected a network drop. So this is the configuration used in XIFI for the specific quality of service management features. Details on how to configure and use quality of services in XIFI can be found in use case MG2. Here we use bots simulating the 2 classes of clients of a game. They were hosted at the XIFI Lanyon node, while the server was deployed at the XIFI Trento node. And finally, this is the configuration run on Ofertie, the experimental environment. It's similar to what was shown in the previous slide, with opening new priority channels for priority users when the traffic load requires them. And so we set up a list of qualitative metrics we defined to evaluate the features offered by different facilities at the differing stages of the innovation pathway. They include SDN support, of course. We needed programmable switching of network routing in response to increases in network load. This could either be native support or via our own installed SDN software, such as OpenFlow. We wanted QoS monitoring so that we could see in real time what the level of QoS was, throughput, bandwidth, latency, packet loss, etc., in order to base decisions about when to switch network routing. This could be via access to network switch counters, such as Floodlight, or native measurement logs from the testbed itself. External IP addresses were needed since we wanted real Minecraft players to engage, and so they would have to have access, they would have to connect via the external IP addresses. We also wanted to provide static domain names system visible IP addresses so that we could register the Minecraft server with publicly available server listings to attract real players. It was important to be able to isolate the network slice from other traffic occurring on the testbed from other experiments. This was really critical, as we will be measuring patterns in network traffic and trying to do behavior classification and SLA violation checking against it. We needed a testbed that provided a reliable network slice that was stable for the several days each experiment would last. Major peaks in network performance or downtime would generate noise for the experimental results and probably render them useless for analysis. Of course, we wanted ease of access to the testbed slice, and we were working remotely to access the Minecraft server via standard tools such as SSH. The more difficult and unreliable access to the server, the more time-consuming it would be for the experimental testbed to provide sufficient network and server resource to run the experiment. We wanted a testbed helpline support because if problems did crop up, we would need fast and effective responses to solve the issue and resume the experiment. Support would be needed in both the experimental setup and the runtime phases. And finally, the cost of testbed provision had to be affordable in relation to the benefits gained from running the experiment in the first place. And so this is a high-level view of what we actually found. Details are in the paper that we referred to in the last slide. Commercial facilities provide you with everything in a neat bundle, but no SDN support. This, of course, is absolutely crucial in specific applications like ours. XIFI imposes certain trade-offs, but all in all provides services no other infrastructure can offer. And finally, experimental facilities too are very interesting from a theoretical point of view, but suffer from serious limitations when used for large communities or when operational support is important. And so here are the main recommendations and findings that came out of the experiment. For aging software and hardware, we need to identify from the start a sustainable funding strategy to allow better support for experimenters. Any lack of dedicated support and regular incremental upgrades means that the cost-benefit ratio of running a network experiment is no longer viable. We need full support. We recommend full support. At present, no testbed class fully supports the range of network experiments researchers are working on today. Experimental testbeds follow a closed sandbox type approach, which prevents experiments from scaling up and often rule out traffic coming from external ISPs. And finally, the pre-commercial and commercial class testbeds follow a scalable cloud data center type approach where network resources virtualized and therefore true network isolation is impossible, or anyway not possible to make available externally. But finally, there is real opportunity in the future for pre-commercial class testbed facilities to offer something different from commercial cloud offerings. So the work we presented here is the subject of a paper at the IEEE NetSoft 2015 conference. This video is available among the XIFI Showcase Presentations Year 2 on YouTube, and the XIFI Showcase Year 2 presentation MG2 shows how to set up and manage quality of services in XIFI is available from the same channel.